Given these three sets, A, B, and the universal set, perform the given indicated operations. Our first question is A union B. Remember, to do this, we're going to take every element that is either in A or in B or in both. So if we go through this list, we know we're going to need an X and a Y and a Z because we need every element from A. So we have all of those taken into account. Now we need to go through and use every element from B. So we'll also need to throw a W into this list. We're going to need an X, but we already have one. We're going to need a Y, but we already have one of those. So now we know that A union B is finished. Question 2 is A intersect B. This is the set of elements that's common to both A and B. So if we go through our list, we ask the question, is X common to both lists? And yes, it is. So X will be in the intersection. Is Y common to both sets? I see that Y is in A, Y is also in B, so Y is common to both. And then is Z common to both? And I see that it's in A, but it's not in B. Since we've run out of elements, that's it. The intersection is the set containing X and Y. For question 3, A minus B. This is all the elements that are in A but are not in B. So we're going to start out with X, Y, and Z. Those are the elements that are in A. And one by one, check these against the elements at B and take them away. So is X in B? Yes, it is. So we're going to subtract that out. Is Y in B? Yes, it is. So we'll subtract that out. And then is Z in B? No, it isn't. So there's no need to remove it. So that says that A minus B is the set containing just Z. Question 4, B minus A. This will go the same way. We'll start out with all the elements that are in B, W, X, and Y. And one by one, we'll take these out as they occur in A. So is W in A? No, it's not, so we leave it in there. Is X in A? Yes, it is, so we're going to take that out. Is Y in A? Yes, it is, so we're going to take that out. This leaves us with just the set containing W. Question 5, A complement. This is the set of all elements that are not in A. So we start with the universal set, V, W, X, Y, Z, and we're going to take out those elements that are in A. So we don't want to include the X or the Y or the Z, so we don't want to include any of these. We only want to include the V and the W. So that's A complement. The product of A and B. Remember, this is the set of all ordered pairs where the first element in the parentheses comes from A and the second element in the parentheses comes from B. So if we write this out, first, A, if we run through all the elements in A, we have X and Y and Z. So we're going to have ordered pairs. Our first ordered pair starts with X. We're going to pair the element X with W. We're going to pair the element X with X. We're going to pair the element X with Y. So we've handled every ordered pair that starts with X. Now we move on to the Y's. So we're going to have ordered pairs that start with Y. Y is paired up with W. Y is also paired up with X. And Y is also paired up with Y. That handles all of the ordered pairs beginning with Y. Finally, we have the ordered pairs starting with Z. So Z gets paired up with each of the elements from B. So Z is paired up with W. Z is also paired up with X. Z is also paired up with Y. We've now run through every element of A and paired it with every element of B. And so we have the product of A and B. And just as a reality check on this, there are 3 elements of A and there are 3 elements in B. 3 times 3 is 9. So we should have 9 elements in the product. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That just verifies that we didn't miss anything. Question 7. The product of A with B with A. So this consists of all ordered pairs where the first element comes from B, the second element comes from A. So if we look at the elements of B, this starts out with W. So we're going to pair W with each of the elements from A. So W is paired with X, W is paired with Y, and W is paired with Z. That takes care of the W. Now we're going to move on to the X. We're now going to pair X with every element from A. So X gets paired with X gets paired with Y, and X gets paired with Z. That handles the X. And now we'll move on to the Y. And we'll pair Y with every element from A. So Y gets paired with X, Y gets paired with Y, and Y gets paired with Z. Now there's something to note on here. Since the A and the B in question 6 just switched places, the first was A times B, the second looks like B times A. All that should do, the same ordered pairs should be in our list, just with the first and second coordinates switched. So if we look at this first element, this is X with W. The first one in our second list is W with X. We just switched the role of the X and the W. So we have X with X. We also have X with X in our second set, and so on. So this just gives you a second way to check that you've done the product correctly. Question 8 is the power set of A. This is the set of all subsets of A. So we're going to start out methodically. We begin with all those sets with no elements. There's only one set with no elements, and that's the empty set. Then we look at all the subsets with one element. So we could have the set containing just X, or the set containing just Y, or the set containing just Z. So those are all the singleton sets, the singleton subsets of A. Then we're going to look at all the doubles. So we could have X and Y, X and Z, Y and Z. Those are all the subsets with 2 elements. And then finally we look at all the subsets with 3 elements, and there's only one, which is the entire set, X, Y, and Z. Now, to make sure we have the right number, A had 3 elements, so it should have 2 to the power of 3, or 2 times 2 times 2, which is 8 subsets. So if we just count to make sure we have enough, 1, 2, 3, 4, 5, 6, 7, 8, we know we have all the subsets, and so we've got our power set.